Okay, here is the week 14, day 2. And our topic for this video is solving systems with 3 equations instead of just 2. And so I picked 2 examples to do here, and the third example will be your attendance problem. So let's first start with this one. We want to solve the system, and this system consists of 3 equations. We have 4x minus y plus 3z equals 0, minus 2x plus y plus z equals minus 8, 3x minus 2y plus 4z equals minus 4. And so there's a few ways you could go about solving these. I'm just going to go ahead to show the way that for me makes the most sense. So really what you want to do is somehow use adding or subtracting and also multiplying by constants on these 3 equations to make 2 equations of just 2 variables. So first let's first start off with the first 2 equations. That if I were to add the first 2 equations, say this one and this one, then you'll notice that this y variable will go away. So notice how the y variable on one's a negative and on this one is a positive. If I add this first one to the second one, the y's will cancel. So that's going to be my first step, is to add equation 1 and equation 2. So let me just write this out here. So I'm going to take 4x minus y plus 3z is equal to 0. And I'm going to add the next one, minus 2x plus y plus z. And this is equal to minus 8. And so to find this addition of equations, you just add the like terms. So I like to think of it as you're adding the columns like this. So we have 4x minus 2x is just a 2x. Minus y plus y is a 0, so plus 0. 3z plus z is a 4z. And then we have equals, and then 0 minus 8 is a negative 8. So from this, let's just write out the equation without the 0. We get 2x and plus a 4z is equal to minus 8. So let's just keep track of this one. So I'm going to put a box around it so we can keep track of it. Now we want to make one more equation with variables x and z. So let's now look at equations, for example, 2 and 3. So if you'll notice, we want x and z, so I want to get rid of the y variables here. So if I were to have a 2 in front of the y in this second equation, and then we could add, then the y would cancel. So for my next step, I'm going to take 2 times the second equation, which will give a 2 in front of this y. And then I'm going to add 2 times that I'm going to add that result to the third equation. So that will make sure the y's will disappear. So I'm going to do that down here. So first on the top, I'm going to take 2 times the second equation. That just means multiply each term by 2. So 2 times minus 2x is a minus 4x. 2 times a y is just a 2y, so plus 2y. Then plus 2z is equal to minus 16. And then below, we just keep the third one the same. So we're going to add this third equation. So plus 3x minus 2y plus 4z equals minus 4. And so we want to take the sum of these. So we just add column by column. So we take sum the x's, then the y's, and then the z's. So minus 4x plus 3x is a minus x. 2y minus 2y is a 0, so plus 0. 2z plus 4z is a 6z. And then equals, and then minus 16 minus 4 is a minus 20. And so I'm just going to over here, below the first equation we found, write this one without the 0. So this is minus x plus 6z is equal to minus 20. And we'll put a box around this so we can just remember it. And I'm going to erase some stuff here so we can make some more room so we can work with these equations. And so now what we've done is we've made two equations of just x and z instead. Now we know how to solve systems of two equations. So basically, remember, we eliminate one of the variables, then solve for the other. So for example, we can eliminate x, then solve for z, and then plug in that value to any equation and get x. So what we're going to do is use these two equations, and I'll say it's easier to get rid of the x. So notice in the second equation here, if we could get a 2 in front of this x, so it would be minus 2x, we could add the two equations and eliminate the x. So therefore, I'm going to multiply the second equation by 2 and then add it to the first. So up here, I'm going to do that. So I'm just going to write the first equation. So that's a 2x plus 4z equals minus 8. Now we're going to add 2 times the second. So we put plus, and then everything we're going to make in the second line is going to be 2 times the first equation, the second equation. So 2 times minus x is a minus 2x. 2 times the 6z is a plus a 12z. Then equals, and then 2 times minus 20 is a minus 40. And so we want to find what this sum is equal to. So of course, you take 2x minus 2x, that's a 0. 4z plus 12z is a 16z, so plus 16z. Minus 8 minus 40 is a minus 48. So just off to the side, what is this? This is 16z equals minus 48. And so we can simply solve for z by dividing by 16. So on the left, we have a z. And on the right, we have minus 48 divided by 16, which is minus 3. So we've solved for our first variable z, which is minus 3. Now, just like the previous problems when we had systems of two equations, we can solve for x by plugging in this value of z into any of these equations. For example, plug it into this one. So what do we get? We get 2x plus 4z is plus a 4 times minus 3. 4 times a minus 3 is a minus 12. So this is the same as taking minus 12. And that's equal to a minus 8. And I'm going to add 12 to both sides. So this 12 and this 12 cancel. And so we have 2x equals, make sure I have everything neat. Minus 8 plus 12 is a 4. And so to solve for x, we just divide by 2. So dividing by 2 on both sides, we get an x on the left. 4 over 2 is a 2. So we found the second variable is x equals 2. And this has 3 variables in it, x, y, and z. So we have x and z. We now need to solve for y. And so down here, I'm going to erase some stuff so we can do some algebra down here. So how do we solve for the y variable? Same idea. We found the previous variable. Just pick any of the original equations. For example, let's do this one. And just plug in minus 3 for z and 2 for x. So we have minus 2x becomes minus 2 times 2. That's a minus 4. Then plus y, since we don't know what y is equal to. Plus z becomes a minus 3, since z is a negative 3. and this is equal to -8. So we have -4 minus 3 is a -7. So we have y minus 7 equals -8. And then to solve, just add 7 to both sides. Cross out the positive and -7. And then so over here we get y equals -8 plus 7 is -1. So here we have our solution to the system. We have that y equals -1. We have that x equals 2. And we have that z equals -3. Okay, here's the second example I would like to show you. We have the system of equations, which we want to solve. Y plus 2z equals 4. 3y minus 4z equals -18. 2x plus 2y minus z equals -5. And so remember how in the first problem, we did some addition and multiplication of some of these equations, and we ended up creating these two simpler equations that just had two variables. And then we solved the system of two equations. Well, basically, we're going to use the same idea for this problem, except that first step of finding the two equations of two variables, we don't even have to do, because these two equations are already in that form. We have two equations of two variables. And so basically our technique is going to be to solve these two equations for y and z. And then into the third equation here, we're going to plug in the values of y and z we find to solve for x. So let's go ahead and do this. So let's first solve the equation 1 and 2 for y and z. So the easiest way to approach this is you'll notice that in front of a z we have a 2, and in front of the second z we have a -4. If I were to just multiply the first equation by 2, then this 2z would become a 4z. And then if I were to add the equations, I could eliminate the z's. And so that's exactly what I'm going to do. We're going to take 2 times the first equation and then add the second. So 2 times the first will be just 2 times each variable. So 2y plus 4z is equal to 8. 4 times 2 is 8. And then we're going to add the second. So we add 3y minus 4z and equals -18. And so we just add these, just add along the columns, making sure the variables match up. 2y plus 3y is a 5y. 4z minus 4z is a 0. And equals, and 8 minus 18 is a -10. So off to the side, what this really is without the 0 is just 5y equals -10. 5y equals -10. And so to solve for y, we just divide both sides of this equation by 5, which gives us a y on the left. And on the right, we have -10 over 5, which is -2. So we have our first variable, y equals -2. To solve for the z, we just go to any of these two equations. For example, let's pick this one, the first one, and substitute -2 for y. So we get -2 plus 2z is equal to 4. Then we add the 2 to both sides of the equation. So these cancel, and we have 2z is equal to 4 plus 2, which is 6. And so to solve for z, we just divide both sides of the equation by 2. So we divide by 2 on the left, and we divide by 2 on the right. So we have 2z over 2 is just the z. 6 over 2 is 3. So we have our second variable, z equals 3. Now we have y and z. We have specific numbers for these. So if we want to solve for x, we go to this third equation here and substitute 3 for z and a minus 2 for y. And then we can solve for x. So I'm going to do that over here. So we get 2x plus 2y is plus 2 times minus 2. 2 times minus 2 is a negative 4, so that's the same as taking minus 4. Minus z becomes minus 3. And this is equal to negative 5. So the minus 4 minus 3 is the same as a negative 7. Let me just rewrite this here. So that's 2x minus 7 is equal to negative 5. Now we add a 7 to both sides. Cross out the positive and the negative 7. And so we get 2x equals negative 5 plus 7 is a 2. And so we'll find x equals 1, since if you divide both sides by 2, we get 2x over 2 is just an x. 2 over 2 is 1. And so for our solution, we have x equals 1, y equals negative 2, and z equals 3. Okay, so for your attendance problem, I picked another system of equations. And, oops. So I'll give if you don't see how to start this, I'll give you a hint. And so I'd like you to do is just for your attendance, solve this problem. Find the values of x, y, and z. So if you don't know how to start, I'll give you a hint of how to get started. So in this one, I'm going to show a third method. And so what we want to do first is take this equation here, this first one, and to solve it for z. Since this is very simple to solve for z, you just add 2y to both sides. So if you solve this first equation for z, you get z equals 2y plus 7. And so this gives a nice formula for z. And then the next best step to take once you have z is substitute in this value of z here. So let's just calculate that. So we get 3x minus 2. And instead of z, we're going to place this formula 2y plus 7. 2y plus 7 equals minus 8. And so I'm just going to simplify this real quick. So you get 3x minus 4y minus 14 equals minus 8. And then if you add a 14 to both sides, we get, so you get 3x minus 4y. These cancel, is equal to 6. And so we have here is the second and the third equation after we've substituted in z, form a system of two equations, and the variables are x and y. So what you're going to want to do is take this second equation and this equation we just found and solve them for x and y. So this is my hint, is you want to solve the system x plus 4y equals minus 14. 3x minus 4y equals 6. And then, so you'll find x equals something, and you'll find y equals something. Once you found what y is equal to, you're going to take this number and plug it into this formula for z and get z equals something. And so you'll have your solution x, y, z. So here's my hint: as you solve this system of two equations, find x and y, and plug y into this formula to find z. And so this ends all I have to go over for today.